before I do anything else, I'm going to ask, quick check one. Did you guys have any questions? Would you like to see any of the evaluating f of -1, f of x squared, f of t, or f of p minus 1? Yeah. Which one?
Can you do the last one?
The last one? Sure. One thing I'm going to say about f of t right away, notice if you have x squared minus 2x, it becomes t squared minus 2t. That's pretty clear, right? But then when you start to throw in something else, like a p minus 1, yeah, maybe a little trickier. So let's take a peek.
You did not have to use the quadratic for p squared minus 4t plus 3.
Oh, suppose you had to solve for the zeros or something. Then yeah, that might be something you might do as quadratic formula or factoring. I mean, there's a lot of things that are going to come back from algebra as you guys start reviewing this stuff. But for this, let me just work out the exercise. So let me go to a fresh page here. Okay, so let me label too. This is section 1.1. This is quick check number 1. And so it was f of x equals, remind me, x squared minus 2x. Okay. And we're supposed to find now f of p minus 1, correct? What that means is everywhere it used to say x, I'm going to substitute in p minus 1. When you have a function, you substitute things in. I like to put them in parentheses. Actually, even if you're doing the -1, if you put it in parentheses, that'll help you keep things straight. So I'm going to have p minus 1 squared minus 2 times p minus 1. That's the answer. Probably they want you to simplify things, right? So again, well, there's some classic algebra mistakes I could make if I'm not careful, right? So for example, here, what's the classic blunder? To write -2p, but what do I want to write? I want to write plus 2, because I have to distribute that negative, right? What about this guy here? The classic blunder is just to write down another binomial. But when you square a binomial, you get a trinomial, right? Because you do first, outer, inner, last, and the outer and inner kind of combine. So if you work out, you know, p minus 1 times p minus 1, you're going to get p squared minus 2p plus 1. Is that okay so far? And now I'm going to combine like terms. And so I'm going to get p squared minus 4p plus 3, which is what they said the value of f of p minus 1 is. Okay? Questions on that? So if we go to chapter 1, section 2 next, I'd like to do that. Let's see. Yeah. All these different kinds of functions. How do people think they know what polynomials are? Polynomials. Okay, maybe not. So if this is a difficult section for you, one thing you might want to do is, well, again, this is what we're supposed to do for Wednesday, right? Is prepare by spending part of your time reading section 1.2 and doing the quick checks. Well, let me do a little bit of it now with you. A little bit of it now, because there's plenty to do to get started. So I'd like to do this. Instead of doing exactly what's written here, I'd like to just start getting some examples of different functions. So Joe Dempsey, can you give me a function?
Y equals x.
Nice. And if you don't mind, I'm going to write f of x equals x, just to use this input-output notation. So f of x equals x. Maybe I'll call this f1 of x. It's the very first function we came up with in our class. Joe, what do you know about that function? Anything?
We don't just make a diagonal line.
Yeah, diagonal line, 45-degree angle, because the slope is 1. Okay, so that's kind of nice. We'll go from there. Josh, can you give me another function? I'll call it f2 of x. So if you say x equals 2y, that's interesting to me. I'm trying to write with the function notation. And I should point out that Joe did the same thing. He said y equals x. And I changed it to function notation. Instead of writing y, I wrote f of x. If you write x equals 2y, I can get the y by itself, right? You guys, what does y equal in Josh's example here? 1/2 x, right? So I'm going to say that Josh's example is 1/2 x. What's the graph of Josh's function look like? Oh, okay. So what shape? I mean, it's a line, right? But you're right, a 30-degree angle, right? You're picturing not a 45-degree angle anymore, but the rise over run is 1 and 2, right? So, yeah, now you're talking 30, 60, 90 triangle. That's interesting. Okay. So let's get another example. Mike, give me a function of some kind. X squared. How is Mike's function different from the first two? If you graphed it, what would you have? A parabola, right? It's a nonlinear function. So we start off learning about lines, and then we learn about nonlinear functions. So far, all of these functions are polynomials. I can also get a polynomial by adding polynomials together. So I'm going to make one up. f4 of x is x squared plus 1/2 x. That's a polynomial. Plus 7 or minus 7. You can add and subtract x to some power like this, and those are all called polynomials. Okay? So these are examples. The reason I wanted to write these examples on the screen for you is because you said, I don't know what polynomials are. Well, here's an example of what are called polynomials. And those are usually the first functions that you study. Okay. So I guess what I'd like to do is, could we pause for a second and everybody talk to the person next to them, and can you come up with an example of a function that is not a polynomial? And then we'll put some of those up on the screen. Time. That's why I needed you all to be working. Let's get some examples of functions that are not polynomials. Any volunteer have one for me? Go ahead, Calvin.
F of x is equal to I.
Equal to what?
Equal to ix.
Ix? Now that's interesting. Why is that not a polynomial, you're saying? Because of which part? The I?
Yeah.
Let me write that over here. F of x equals ix. This is an interesting thing because can the slope be the square root of -1? Let me give you a little saying that I'm going to use quite a bit in this class. Guys, keep it real. Okay? Because I would argue that this is a polynomial, but it's so out there that we're not going to talk about in this class. Keep it real. Okay? That's a cool example, though. Other people had hands up. Give me another function that you came up with. You got another one, Mike?
Y equals 1.
How about that one? Is that a polynomial? If I write f of x equals 1, could you graph that?
Yeah.
What does y equals 1 look like? Well, yeah, it'd be parallel to the x-axis, right? It has a slope of 0. I'm going to call that a polynomial. Okay? It's funny. Most of the functions we think of are polynomials. Did anyone come up with one that's not a polynomial? Not yet. Well, good thing we're looking at the book. Let's take a peek. So what do they say are things that are not polynomials? Ah, how about that one in green over there? Can I have an example of a trigonometric function? We've had a couple today. What's that?
The cosine of x.
The cosine of x. The cosine of x is not a polynomial. Sine of x is not a polynomial. Actually, those functions are special. They're called transcendental functions. And you guys have studied those quite a bit. And if you look at the calendar, my plan, Friday, okay? We're going to have some special time devoted to trigonometric functions. Okay? Those are not polynomials. They're extremely important, though. And so we're going to make sure we spend some time on those right away. Remember how I said you can get other polynomials by adding polynomials together? What else can you do to polynomials? You could subtract them. We did that up here. We subtracted some polynomials up here, and we got a new polynomial. Great. Can we multiply polynomials? Yeah, if you multiply two polynomials, guess what you get? A polynomial. Can you divide polynomials? Well, that's interesting. If you divide polynomials, and let me use this for my next example. Can someone give me a polynomial, please? Go ahead.
Let's see here.
Brad, what do you have?
X squared plus 3 to the second power.
Okay. I could just call it 9 then, right?
Okay, yeah, that's fine.
Cool. X squared plus 9. X squared plus 9. And B, can you give me a polynomial, please? X squared plus 9 over x plus 1. This here, I took a polynomial and I divide by a polynomial. And I'm going to tell you that this is an example of what is called a rational function. And it is not a polynomial. And deep down inside, there's an evil, mad slasher that wants to say they can cancel the x's or something like that. But you can't because of the plus signs. Right. So this is a different kind of function that we're going to be studying quite a bit. Because it's one of the first examples we come up with that is not a polynomial. If you divide two polynomials, you don't always get a polynomial. You get something else. And one of the reasons I like this example, you guys may have seen when I was flashing through the book, it talked about function, and the very first thing it talked about was domain and range. You guys, polynomials are kind of boring when you talk about domain. The domain of a polynomial is any real number. But this function here is the domain changed, right? Why can't x equal -1 here? Why?
Divide by 0.
You'd be dividing by 0, so the function would be undefined, right? So here's an example of something that has a more interesting domain. Okay? And so that's one of the reasons you talk about rational functions. Okay, so back to my picture of what we're looking at. No, that's not it. Let's go back to my picture, like I said. Here. Okay? Oh, they show these subsets. It says that polynomials are a subset of the rational functions. So here, are all polynomials rational functions? Well, that answer is yes. Are all algebraic functions polynomials? No, I just showed you a rational function that's not a polynomial. Okay? And they talk a little bit more in the book about exactly what these things are. But back to my notebook here, how do you show that these polynomials are rational functions? See, there's another way I could write this f4, right? I could take f4 of x and write it as x squared plus 1/2 x minus 7 over 1, right? So now you can see it's a rational function because we said f of x equals 1 is a polynomial. So if you take a polynomial divided by a polynomial, that's what a rational function is. Okay? So when you do very simple things to polynomials, like divide or multiply, or even take square roots, That's what it means to be algebraic. But when you start talking about sine and cosine, those are very different. Those are called transcendental. And at the start of the course, we'll talk about algebraic functions and we'll talk about trigonometric functions. And when you get to chapter 7, that's when we're going to talk about these, exponential and logs. You guys did that in your pre-calculus at some point, right? Well, it comes back, but we wait on it for a while. We said, let's do calculus without those for a while. Our book is not what's called early transcendentals. We wait on it. Go back to it in chapter 7. So, I guess what I didn't quite finish today, which is fine, is I didn't quite finish the whole story on these two problems. The tangent line problem, we know that's one of them. And the area under a curve, we haven't seen that at all yet. We'll have to do that next time, okay, or maybe Friday. But at least you have these names of these problems. I think you have how the system works, and I will see you guys on Wednesday morning.